Hi everybody, thanks for coming to this talk. I'm Chris O'Connor, Technical Director at ZeroLight, and this talk is working with more car configurations than there are atoms in the known universe. So what it's basically going to cover is how we work with large amounts of data and how we ensure the product we deliver is always of the highest quality. So to start with, how many atoms are there in the known universe? So according to the internet, there's 4 times 10 to the power of 79 about atoms in the known universe. Some crazy mathematician has done some algorithm to work out how many there is, and this is the number he comes up with. So what this number actually looks like is this crazy big number. So it has 81 decimal digits, which is obviously crazy. These are numbers we never want to have to deal with. So how does this relate to what ZeroLight do? So what we do at ZeroLight is create ultra-realistic car configurators. We allow our customer to customize and explore every part of the vehicle. So as you can see in this video, it shows some examples of our configurations on an Audi R8. So you can change alloys, paints, trim, lights, seat fabric. There's hundreds of different interior parts. There's hundreds of different fabrics that you can choose. Basically, the number of parts is absolutely crazy, and there's no way that they can visualize these in the marketing brochures. So what we try to do is create a solution where you can see every single part, every single configuration. So how many actual configurations are there? In this case, for the Audi cars, there's 200 swappable parts about per car. There's round about 1,000 different materials that are built for every car that are on each part. We have 13 different car ranges and 3 different model years. So this works out as 3 times 13 times 1,000 to the power of 100. So this number looks something like this, which is even more crazy than the number of atoms in the known universe. So there's 602 decimal places. But really, when we look at actual legal configurations, there's a few less. So on average, we have 100 swappable parts, 10 different materials, still 13 different cars and 3 different model years. So as far as legal parts, they're like you can't put fabric on the exterior of the car. You can't put carbon fiber on your seats. So we can't take every single material can't be placed everywhere. So what there is to decide these legal parts is a rules engine which says these are what we're allowed to sell. It's restricted down, so you can't have like in the case of Audi, you can't have an S-Line badge on a non-S-Line car. So this works out about the average. So this is still 3 times 13 times 10 to the power of 100, which is about the number of legal configurations we have to deal with. So what this works out as is still a massively crazy number with 102 decimal digits. So it's still, we cannot test all this data. We cannot look at every possible configuration. There's no way that everything can be tested. So how do we deal with so many options? So this is the same for any product that you're creating, whether it be a configurator, a game, an application. We always try as much as possible to avoid human error because that's where issues appear. We try to do as much automation as possible. The more you automate, the less QA time, the less testing that needs to be done, and the less hours that need to be spent on the testing by your team. So we also try to reduce the data subsets. So we try to find the worst cases, find what we should be testing every day, the things that generally go wrong. We have automated testing, and reporting, and this creates an easy solution for everyone to quickly see the results, quickly test. And of course, blame. Like, if we find someone to blame, someone's broken it, we can make sure this doesn't happen again in the future. So these are the simple stages that we try to follow, and we try to make our product as stable and as high quality as possible. So I'll go through each of the stages. So to start with, avoiding human error. So this is what our build versions look like. It's very easy for people to get confused. Yeah, some humans can't count. We had so many problems where people would see a number and they would switch around like the date all the time and get the wrong build, not get the latest build, and we would end up getting the incorrect build sent out to our clients. So, best solution, all computers are brilliant at counting. They know what they're doing. So it's better that if you can automate this process, let the computer do it, and then there's no chance of there being an error. Back up and log everything. So if something goes wrong, you know where it's gone wrong, you can track it down, and you can put measures in place to stop this ever happening again. Everyone's PC is dirty. So when you check out code, everyone says it's clean. We can do a build off our machines. There's no problems, but never trust them. Everyone has local changes. Everyone has custom code to get around a problem that may be just on their machine. So the solution to that is we use Jenkins. So we build all our applications every night. As long as we have a build every night, if something goes wrong that hasn't been spotted, we can quickly go back and test it. Our main application is built after every single check-in, and that ensures that whatever's gone in can be tracked, can always be logged, which then goes on to the automated testing. So by building on Jenkins, it ensures that we have no risk of local changes on local people's PCs creeping in. There's no chance of issues occurring that would be localized to someone's PC. So it's very simple to set up. We have it set up on a server. You can set it up on a desktop PC. It takes 5 minutes, and it's very simple. So reducing data subsets. We try to choose the best and worst case. We can't possibly test everything. As you've seen the numbers that we're dealing with, it would take more time than we have in the rest of our lives to go through every single combination. So we choose things that are generally going to be touched, things that are going to be switched, things that we know are a little more complex. So we do alloy swaps, car line swaps, paint swaps, and interior swaps. And these particular things we constantly check. We constantly ensure that there's no issues with these particular things, and even with this subset of data, we can pretty much guarantee that the majority of other things will work correctly. So we also test the things that typically break. So for us, it's complex materials like difficult paints, speckles, multi-layered fabrics and materials. We constantly check frame rate. For us, frame rate's very important, having to get it running on Vive and at 60 FPS on 4K. If we drop a single millisecond, it means that there's going to be problems, and our clients are going to be complaining about issues there. And of course, loading times. As we're dealing with the general public, they don't understand that in computer games, you have to wait for a level to load. They just want everything instantly, so we have to ensure that our loading times are as low as possible, and we have no issues there. So we constantly check them every day. So the testing that we do is as automated as possible. So this is one of the graphs that we created. So this is testing subset data, testing the FPS on a range of models, a range of hardware, to ensure that it meets the criteria that we expect. And with graphs like this, it's very clear when something's gone wrong. When we've been given our QA staff tests to do, so we say test the frame rate, make sure that it hits the correct FPS. They'll often not do consistent results, so they'll have the camera set up in a certain location. They'll have a different car model, a different environment, and this results in the tests not being accurate. As this is automated, it means that there's no problems. The computer's doing the exact same thing every time, and they just need to look at the results and see when something goes wrong. But of course, always be careful that there's not too much data in the reports, as having too much data is as bad as having no data. We've seen cases where we would get big reports of all the changes. It would run every night, and people would end up just ignoring this, and there was no point running it in the end. So make sure your data's concise, make sure people are checking it, and if there's a reason they're not checking it, then find out why not. So as for blame is often seen as a bad thing, and like it shouldn't be seen as negative. It's not always bad. What we're trying to do with blame is try to find out why it was broken, who broke it, and how it can be fixed as soon as possible. So if you find who was responsible for that check-in, we can discuss and find out what it was meant to do, track it down as quick as possible, and ensure that the product we're delivering doesn't have any issues that have been missed or will cause problems in the future. As I say, it's all about getting it fixed and preventing it from happening again. The more you educate people, the more they will know to look out for these issues and ensure that they don't happen again. So the systems we have at ZeroLight, we obviously use Jenkins to build code and assets. Every night the code will be built, every night the assets will be built. The assets that we deal with are absolutely massive. So typically a car is about 3 GB. So we build these, I think it's about 30 cars we build every night, including the released and unreleased ones to test. This takes a lot of system power and a large amount of time. But by automating it, if we get a broken build, we can look back and find a build that will work. Sadly, our IT department isn't very happy about this because it fills up all the servers, but it's more important that the product is out there and hard drives are cheap enough. We also have automated testing. So we have tests, reports, and traffic light displays around the office to always ensure that the builds are as stable as possible. So with our actual Jenkins build system, we started with a single job, our main application. We'd build it whenever we could, and now we've expanded it. We have over 1,000 jobs. We're constantly testing everything, every version. If we suddenly find that we've released a new version to one of our clients like Audi, we can look back at the previous one, run the tests on that, and see what has changed. It logs all the source control logs, so you can always see the changes that have happened since the last time you did an actual release. And compile tests are essential. So on the Jenkins server, we run compile tests constantly. If someone checks in some code into a shared repository, we have to make sure that that works across all the products, and that because there's so much shared code, we originally had issues where someone would check something into the main application, and it would prevent all the environments from building, or the other demos from building. So it's really easy. Set up a job, set it building. If there's no errors, then it's fine to go. So as I say, it's an easy sequence. Set up a compile job, set up a job to package the actual installer of the application. We run tests, and then we display reports. So this is our build status. A nice plugin for Jenkins. There's loads of plugins available that'll do the majority of things that you need to do. So this is the build monitor view. This is the green balls plugin that we use to highlight whether it's failed, it has errors, it has problems, or it's succeeded. For using with Unity, we use the Unity 3D plugin, which just launches Unity. You don't have to worry about sending up any batch commands or anything like that. It's just simple 2 lines of logic in Jenkins. It will launch Unity, build your application, and then we have the log parser plugin, which will then parse your logs and highlight any errors, any warnings, and it's easy. Like, we even have our art team looking at the logs so that when they check something in, they can see if there was any errors in that build. So if it's ran out of memory, or it's failed to build the actual bundle, it's so simple to use that anybody can use it. And there's loads of plugins available if you're working on mobile games, if you're working on PC applications. There's plugins that will automatically upload your content to the cloud, upload it to a device. We create configurators on the iPad, and we have iPad jobs that will automatically go to the Mac machines, build on the Macs, and then deploy to the iPads and iPhones, so that when the QA team get in the morning, they can fully test the build without any waiting around. So this is in the office. These are the displays we have all over the office, so we can quickly catch when there's an issue and when something goes wrong. So in this case, it was pretty late at night, and I saw this error. I took a picture for this presentation, and then I left it for someone to fix in the morning. But usually, it will be tackled straight away as soon as this appears in the build during the day. Someone will go and fix it, so we know as soon as something has gone wrong. So automated testing. This is one of the tests we run. So it's really easy to break FPS. People check in new post effects, new modifications to the shaders, and it can quickly cause frame rate to drop. And it's very easy to test. Logging frame rate is simple. Set up some cameras that go between your best and worst case, and you'll get an average result. And we also show these graphs on the same TV screens around the offices, so that it's everybody's responsibility to ensure that FPS doesn't drop and make sure we keep that stable high FPS. So this was an example from last week, and on the Audi A3 Cabrio, someone checked in some broken logic, and it suddenly dropped. We had a couple of builds where there was issues, but it was quick to resolve. I think it was a matter of a couple of hours before that was fixed. In cases that we've had in the past before we had these systems in place, that could have been a week or 2 weeks later, and it could be just before we need to deliver a build, and we would have ended up having to work late nights or weekends in order to fix that. Now we tackle it when everyone's in the office. The person who's caused it can usually fix it fastest, so if they're around, it all works out great. So other automated testing we test loading times, the change in memory overhead. number of draw calls, number of materials, and number of objects. These are all very important to us, but you can basically set up tests to test anything really. As long as you make clear, concise graphs, you can get anyone to glance at them and spot if something goes wrong. So in some cases, there's too much data to test everything every night. We have so many cars, so many different setups that it can take a very long time to run through all these tests and then even review the data. So we set up a system that supports one-off tests. So we don't test every car every night. We run in more detailed FPS tests once a month or after a major change. So this was after an optimization we did for Oculus. So we got a gain across the board, and we also got a big spike on the Oculus configuration. So this is more to ensure that the code that we check in doesn't cause any issues, and we get the results that's expected. And this saves our QA staff hours and hours of work, because if they have to manually go through this, test each car, test each configuration, they're never really happy about doing that, and it's so easy to make mistakes. So other automated testing we do is we capture images of the cars. In this case, we check a generic top-down view. It's very easy to see if something has broken. When we first started capturing these, we had so much data. It was filling our servers to the limit. We was using PNGs because we didn't want any sort of compression artifacts to cause issues with the comparisons. So what we ended up using was JPEG, and we just slightly changed our thresholds, because in this case, as you can see, the difference is clearly obvious when the animations stopped working. You can see the doors are no longer opening. It showed in the difference, and it meant that QA could get straight onto it and ensure that problem was fixed. So sometimes it's hard to notice whether it's a good or bad change, but people are reviewing these. It can't be fully automated when it comes down to graphical testing. And it's very easy to check a selection of cars and a selection of environments with a couple of lines of testing code. And in this case, it's very easy to test animations. We play all the animations and see what has been broken in the latest build. So can you trust your testing software? I'd say the answer was no to start with, but over time it will get better and better. As long as you do log in and you ensure that you have someone looking over the results to start with, as time goes on, it will become more and more trustworthy, and you will use these results as the only results you do. So no longer you'll have to use your QA team to test. I'm not sure I trust this guy. This is some random internet picture. I don't think he's going to get there in time. But I was looking for the image after this, but I couldn't find it. So as for machines, we don't have enough systems to test all this on. The systems we run on are typically Titan X's on i7 machines. In the case of Audi, there's HP Z840s, which are like about 10 grand a machine. So what we do is we use machines that are under spec, like especially for image capture. It doesn't matter if it's running at low frame rate. The image still displays the same. So it doesn't always have to be target hardware. And we also use the cloud to do some of the tests. So yeah, ensure that your reports are very clear and simple to understand. We use the traffic light system everywhere, so as soon as something goes wrong, it's clearly obvious. So in summary, we work with a crazy number of configurations. There's no way we can test every single configuration. There's just too many. But there's a simple set of tools using a subset of data, automation. We can ensure that what we actually deliver is as stable as possible, and we reduce our development times, and we get better results, and the products we deliver to our clients are of much higher quality. So, also, I have a talk on the keynote stage tomorrow. If you want to find out more about what ZeroLight do and the sort of technology that we work on, this is a post-mortem of the previous products that we have been working on, and how we got around problems, and how we had to battle against certain issues. Also, come along to the booth, see our Pagani VR demo. We also have the Gear VR cloud-powered demo and the 4K point-of-sale system. We're just over at booth 1 in the exhibition hall. It was a busy day yesterday, but I don't know what it's like now. But whenever you get a chance, come and chat to us. Also at ZeroLight, we're hiring. So this is Carsten. He's super excited to be working on VR. We're looking for new developers in all roles, both junior and senior. And if you'd like to be part of an award-winning team and push our products to new levels, then come and have a chat. And that's it. Thank you for listening. Cheers.